Hi everybody, my name's Allie and today I'm going to be telling you about the introductory material for Lab 1, examining earth materials and processes. Today we're going to be focusing on density and isostasy. So today I'd like to start by talking to you about what we're going to be doing in the lab. Your goal of the labs today are to understand how to use density, mass, and volume in relation to earth materials. Later on, we'll be talking about the lithosphere and the asthenosphere and how that works in terms of isostasy. To start, density is the measure of how much mass is in a given volume. The symbol for density is Greek letter rho. It looks like a P. Now, the equation for density is very simple. It's mass divided by volume. Mass is given in units of grams. So today in your lab, what you're going to do to solve for mass is put objects onto a scale or a balance, and it'll give you a unit in grams. Volume is the amount of space that an object or a fluid occupies. It can be given in units of cubic centimeters or milliliters. Now, this conversion is very simple. 1 milliliter equals 1 cubic centimeter. Keep that in mind for your lab. When we're measuring volume today, we're going to be doing it in two different ways. One is with a graduated cylinder and the other is with a ruler. To start, to find the volume of water, you can't use a ruler, right? It's a fluid. Doesn't work. So what we do is we use the graduated cylinder. This graduated cylinder has units of milliliters on it, up to 25. So if I wanted to find the volume of water, I'm going to pour up to 15 milliliters. 15 milliliters is my volume of water. But when I'm measuring, it's important to take notice of the meniscus. When you look closely at the water, you're going to get down to eye level and look. You're going to see that the water comes up on the sides. This is called the meniscus. What we want to do is measure the center of the meniscus. As we can see here, we want to try to measure to the nearest 0.1 milliliters. So here, each line is 0.5 milliliters. This long line here is 10 milliliters. The one below it is 9.5, and the one above it is 10.5. We can see here that the center of the meniscus is somewhere in between 10 and 10.5. Doesn't look like it's quite in the middle, so we'll have a rounding estimate and say that the meniscus is at 10.2 milliliters. That is the volume in that graduated cylinder. Now, if you were to take the volume of, say, a block, what you're going to do is use its dimensions to get a unit of cubic centimeters. And how you're going to do that is your ruler. You have length times width times height. So a length in centimeters, a width in centimeters, and a height in centimeters. You multiply all three of those together to get your units in cubic centimeters. So again, this is cubic centimeters, but say I wanted to express that volume in units of milliliters. The conversion is very simple. 1 centimeter cubed equals 1 milliliter. So say this block is 15 centimeters cubed. That means that block is also 15 milliliters. Make sense? Normally we wouldn't express the volume of a block in milliliters, right? We'd use centimeters. Versus a fluid, we would use milliliters. So that's all we have to say about density. Now we're going to move on to isostasy.